Alright, what we're going to be going over here is vector addition, and I'm going to use the tail to tip method. If you haven't reviewed your trigonometry, take a look at the triangles and trig review video that I have, or brush up on your own. So, I'm going to take these three vectors and add them together. These vectors could be velocity vectors, they could be forces, anything that has a magnitude and a direction. The direction which is given by these various angles. Okay, so my resultant vector, my big question mark, I can kind of estimate what it might look like just by eyeballing it. So tail to tip method, I draw the first one, tail to tip. I draw the second one from the tip of the first one, and it goes in this direction. And then I draw my last vector, tail to tip as well. And my resultant vector, which I'm going to draw in black, probably looks something like this. It may not be perfect, it may be smaller. This is not quite to scale. So really what's happening is I'm starting at point A, I'm going 5 units this way, 3 units to the left, and then 4 units down and to the left a little bit. I can also talk about this in terms of triangles. I mentioned in my trig review video that vectors can be broken down into right triangles. So I could say I went 5 units at 45 degrees, or I could say that I went x units to the right and y units up. And then I went y units to the left. And rather than saying I went 4 units kind of to the left and down, I went y units down and then x units to the left. Ultimately what happens is my resultant vector also is a triangle right here. I don't know if you can see it. Right there's my triangle. So it also has an x and a y component, which I can find those by adding the x and y's of all of these component vectors. So I'm going to get right to that then. So here's my 45-degree triangle. Both of these angles are 45, so ultimately it doesn't matter which side is theta because the math will come out the same. So remember SOHCAHTOA? Remember it well. Alright, so I want to write out my x and y components. So, so if my angle is 45 degrees, squeeze it in there, then the sine of 45 is going to be y over 5. Or I can rewrite y as 5 times the sine of 45 degrees. X will be using cosine instead of sine because it is the adjacent side. There we go. Alright, so that was easy enough. My second vector is funny. Funny vector. Alright, now it's just a straight line. How is this a triangle, you say? Well, if we use our imagination a little bit and pretend it's a triangle, then we would have to say that its hypotenuse is 3, its bottom side is 3, so this is why it's a flat line, because its hypotenuse and its bottom edge are the same length. And it has no rise, just run, so this side would be 0. Plus the angle here is also 0 degrees. So we can look at it logically and just say, well, its x component is 3 and its y is 0. Quick review of quadrants over here. Here's my x-axis and my y-axis. So positive direction, negative, positive, negative. If I have a vector pointing into the first quadrant, it's going to be in the positive, positive quadrant. In quadrant 2, it's going to be the negative x, positive y direction. The third quadrant is negative in the x and y direction, and my fourth quadrant is positive in the y direction but negative in the x. So this vector points along the negative x-axis, so its x component is actually negative 3. And there's another way we can prove this. Remember that the angle here of our quote triangle is 0. So let's write our x's and y's as we have been doing sort of up here. So the hypotenuse, and then again here's x and y. So x is going to use cosine, right? So the cosine of 0, and y is going to use the sine of 0. Alrighty, so if you remember what the cosine and sine of 0 are, you will find that the sine of 0 is 0. 0 times 3 is 0. The y is 0. And the cosine of 0 is negative 1, which makes this negative 3. So, ta-da, second way of solving that. Alright, last component, vector, which I'll try to draw kind of sizely. There. That's pretty good. Good enough. Here's our x and our y, and it is 4 units long. And we were given the direction vector from the positive x-axis, and it was given as 245. So 3/4 of a circle is 270, so 270 minus 245 should give us this angle here, which is 25 degrees. Now 90 minus 25 is 65, so theta down here is going to be 65 degrees. All the angles in a triangle should add up to 180. So let's write this out again, x and y. Now this is in the third quadrant, so it has negative x and y values. So 4, the hypotenuse, times, and again, our x here is positioned so that it's adjacent, and y is the opposite side. So cosine 65 degrees, sine 65 degrees. Alternatively, I could have used 25 as my angle instead, and then it would have been sine for x and cosine for y. Because in relation to 25 degrees, x is opposite and y is adjacent. I'm going to use this though. Okay, so now to add up the components to get my x and y's for my resultant vector. So there we go. I've already calculated out these numbers, so 3.54 minus 3 minus 1.69 is going to give me negative 1.15. And then again, adding these up is going to give me my r is equal to 3.54 minus 3.63, which is negative 0.09. So, as I suspected, my resultant vector is pointing down to the left a little bit. So, and it has x and y components, which I just found. Negative 0.09, 1.15. Alright. So now I want to find the magnitude, so I want to find the hypotenuse of this vector. the magnitude of the vector, which is the hypotenuse of the triangle, even. So I can use Pythagorean theorem for that. A squared plus b squared equals c squared. So 1.15, so that's 1.3225, I'm just going to write 1.32 plus 0.0081 is 0.09 squared. That's equal to I'm just going to round it to 0.33. And if we were to take the square root of that, square root it, we would get, I'm going to call this r. That's our hypotenuse, is 1.15. So that would be the magnitude of our vector. Now if we wanted to find the direction of our vector, again, I'm used to finding directions of vectors with regards to the positive x-axis, which means I would have to find this angle here. So I'm going to redraw it. Not really an appropriate triangle, but we'll work with it for now. So I'm looking for that angle so that I can find it with regards to the positive x-axis. You could find it with regards to any of the other axes as well. Negative x-axis, negative y-axis, any of those. But first I'll have to find what this angle is so that I can subtract whatever this is from 270 to find theta. Okay, now, so those are my x and y sides again. So I'm going to go back to my SOHCAHTOA and use tangent. So tangent, and this is phi, I believe, is opposite over adjacent. So it's going to be x over y, or negatives. The negatives are going to cancel each other out, so I'm not going to bother writing them. 1.15 over 0.09. And when I plug this in my calculator, I'm going to have to use, inverse to find the actual angle. And make sure you're in the appropriate mode. Degrees or radians, whatever it is that you're using. I'm kind of thinking in degrees right now. And I'd take whatever angle I got from that, subtract it from 270 to find the direction of the vector with regards to the positive x-axis. Alright, so that is vector addition. Vector subtraction works very similarly, except rather than adding together components, you'd be subtracting them. Really, all subtraction is with vectors is adding in the opposite direction. So shouldn't have to worry about it too much for physics. You'll be doing mostly vector addition. So, all right. If you have any questions or comments about this, please leave me a comment or a message. And thanks very much for watching.